This video is all about slope. Slope is the steepness of a line. So mountains are steep, stairs are steep, lines can be steep, and their level or degree of steepness is the slope. Normally, slope is represented by a lowercase m. So slope is the steepness of a line, normally represented by m. Let's take a look at this particular diagram. In this diagram, we've got a line, and that line, so our graph appears to have a positive slope, and we're going to see this as this line goes up from the left to the right. So we're going to have a positive slope here. Slope, once again, all about the steepness of the line. Let's start by talking about the slope formula right here. The slope formula. And remember, slope is usually recognized with lowercase m. So lowercase m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Remember, these subscripts, they have no mathematical value. They're just denoting a second y value versus a first y value. We saw that when we were talking about arithmetic sequences. Now, the other thing that I want to bring to your attention is the whole idea that slope is a ratio of a vertical change, and that's what this is on the top. The y values are the vertical values, and the x values are the horizontal values. So we have a vertical change over a horizontal change. And lots of times we just call that the rise and the run. Rise 1, run 1, 2, 3. A run of 3. So this line that we see here has a slope of 1 to 3. So slope, y2 minus y1 over x2 minus x1. Another way you might see it is the change in y, also known as delta y, over the change in x, also known as delta x. And lots of times in class, we'll just refer to it as the rise over the run. The rise over the run. That is 3 ways to think about slope. So once again, let's talk again about this line. This particular line does have a positive slope. We just saw it's the same line. Its slope is 1/3. We would say that this particular function is an increasing function. This is an increasing function. The line is rising from the left to the right. It's rising from the left to the right. The slope is positive. Here's a new line. This line has a negative slope. The rise this time is not up, but 1, 2, 3 down, and the run is 1, 2. So down 3, forward 2, or we could say up 3, back 2. It's going to give us a slope that is negative either way. We would say that this is a decreasing function. It is a decreasing function. It is falling from left to right. The slope is negative. A decreasing function has a negative slope. It's falling from the left to the right. So, increasing function, positive slope. Decreasing function, negative slope. Increasing function, rising from left to right. Decreasing function, falling from left to right. Now, 2 last very special lines. Here is a vertical line. It is a vertical line that has an equation of x equals 1. Now, if we think about this vertical line in terms of rising and running, a vertical line only rises. It never runs. It has no horizontal movement. It has no run. It only rises. We will say that the slope of a vertical line is undefined. The slope of a vertical line is undefined. Next, we have a horizontal line. This horizontal line has an equation that is equal to 1. Y equals 1. And the horizontal line only runs. It never rises. It only runs. So, if it only runs and never rises, the slope of a horizontal line is equal to 0. So M is 0. So on our vertical line, the slope is undefined because it only rises. On our horizontal line, the slope is equal to 0 because it only runs. There is no rise. So let's compute the slope using the slope formula. So once again, what is our slope formula? Our slope formula is y2 minus y1 over x2 minus x of 1. The difference in the y-coordinates over the difference in the x-coordinates. And order is important here. So here's x1, here's y1. Here's x2, here's y2. So I like to think about them, I like to line them up vertically and think about them as just doing subtraction. So here's x2, y2. Bring x1, y1 underneath, and then all we have to do is subtract. 5 minus 4 is 1. 6 minus 8 is negative 2. y2 minus y1 is 1. x2 minus x1 is negative 2. This slope is negative 1/2. It is a decreasing function. Let's do it again. Use the same process. The slope is y2 minus y1 over x2 minus x1. So if you'll bring your x1, y1 right underneath and subtract. 7 minus 4 is 3. Negative 3 minus negative 3, take a look at that. Negative 3 minus negative 3. Subtraction of a negative becomes addition of the opposite. Negative 3 plus 3 is 0. Oh my goodness, what must this line look like? Let's take the graph paper and let's graph these 2 points and take a look. Back 3, up 4. Back 3, up 7. Oh my goodness, we're talking about a vertical line. A vertical line has no run. The run is 0. So if we get a slope evaluation of 3 over 0, we know that the line is vertical, neither increasing or decreasing, and we say that the slope is undefined. The slope is undefined when the run is 0. Let's do it again on the last pair of points. This is x1, this is y1, this is x2, this is y2. Let's put x1, y1 underneath and let's subtract to find the slope. 3 minus 1 is 2. Negative 5 minus negative 2 is negative 5 plus 2, which is negative 3. Another negative slope, therefore we have a decreasing function. That is how you can find the slope given any 2 points. Now, we have an application here, and it's a new vocabulary word. Points that lie on the same line are said to be collinear. Collinear points. We verify by checking the slope in between the points. So do these relations represent linear functions? Well, let's see if we can graph some of these. So I'll try graphing these and we can see if they're on the same line. So over 3 up 5, over 4 up 7, over 7 up 13, 10, 11, 12, 13. Those kind of look like they're on the same line. Let's check them out. Over 0, down 1. So are we all on the same line? If we are, then the slope will be consistent because on a line, and of course all lines are straight, the slope will be consistent from point to point. So let's check right here. Let's check the rise and the run between these 2 points. So here's the rise and here's the run. So our rise, 1, 2, 3, 4, 5, 6. Our run, 1, 2, 3. So between these 2 points, we have a slope of 6 over 3. That's equal to 2. Let's check. 1, 2 over 1. All right, up 2 over 1. These 2 points have a slope of 2. Now, if we're going to go from 4, 7 to 7, 13, since it's a little bit off the graph, how about we check it with the slope formula? The slope formula, m equals y2 minus y1 over x2 minus x1. So let's plug these 2 points in. So y2 minus y1 over x2 minus x1. So this ends up with 13 minus 7 is 6, and 7 minus 4 is 3, and 6 over 3 is 2. So yes, 1, 2, 3, 4, 5, 6, 1, 2, 3. There we go. So yes, all of these points are indeed collinear, together on the same line. Let's check the other one. This time, we'll just use the slope formula very quickly and check and see if we have consistent slope in between the points. So let's go. They're already lined up on top of each other. So let's find the slope in between these 2 points. So 9 minus 1 is 8. Negative 5 minus negative 1 is negative 4. That gives us a slope of negative 2. Let's check the slope in between these 2 pairs of points. So I will cover up the first point and cover up the last point, and we're going to focus just on these 2 pairs of points. 1 minus negative 4. 1 minus negative 4 is 5, and negative 1 minus 1 is negative 2. Is 5 over negative 2 equal to negative 2? No, it's actually equal to negative 2.5. Do we need to go any further? No, because we have found an inconsistency. And points that are collinear will have a consistent slope in between each pair of points. So the first one was a yes, the second one is a no. Why? Because we're verifying that the slopes in between the pairs of points do not have the same slope, therefore they are not collinear.